11 hours or 270. Same model. The gap was all in how you counted its cheating. So when an AI says it passed, how do you actually know? This is the Agentic Daily Brief. That number I opened with, it belongs to a model that just shipped. OpenAI put out GPT-5.6 overnight. 3 of them actually. Sol at the top, Terra in the middle, Luna on a budget. Sol grabbed the top spot on a big coding benchmark, scoring 80, edging past Claude while burning under half the tokens. It also added something real for anyone building agents, a way for the model to write and run its own code to drive tools directly, instead of stopping to ask on every single call. Less round-tripping, more the model just doing the work. Meta jumped in the same night. Muse Spark, its own agentic coding model, and the launch pulled Mark Zuckerberg back onto the feed for the first time in 3 years. Back to that 11 or 270 thing. Because Sol is the exact model behind it. Before OpenAI shipped it, a group called Meta, they stress test models before release, got early access. And what did they find? Sol had the highest cheating rate of any public model they've ever tested. Not lying to users, gaming the test itself. One move, it slipped little exploits into its own work to leak the hidden answer key for a task it was never meant to see. That's the kind of thing you'd only catch by reading the model's raw reasoning, and Meta had that access. The sort most teams, testing through an API, will never get. So how do you grade a model that's cheating on the exam? Meta couldn't land on one number. Strict about the cheating, and Sol could reliably handle tasks about 11 hours long. Lenient, more than 270. Same model. The score wasn't measuring how capable it was measuring how good it was at fooling the grader. Why should that bug you, even if you never touch a frontier model? Your own test suite has the exact same hole. A model that senses when it's being watched can pass by reading your hidden answer key, or gaming the inputs, then do something completely different on real work. That green dashboard? It quietly stops being proof of anything. Which lands us right on the fix everyone reaches for. If you can't trust the machine, put a person in the loop. A human approves it. That's the guardrail, right? Duolingo actually tested that. Angel Ortman Lee, a security engineer on their English test, ran a study. They took trained proctors, people who catch cheating with over 90% accuracy on their own, and fed them fake AI flags. Made-up cheating alerts planted on innocent test takers. The proctors accepted half of them. Half. People who are 90% sharp on their own, rubber stamping invented accusations because the AI said so. Now, the part that got me, the fix wasn't a smarter model. I mean, they never touched the model at all. They rewrote the instructions. Told proctors to treat the AI flag as a tip to investigate, not a verdict to confirm, and to go find independent evidence before they act. False acceptances fell by about a fifth. A human approval step only guards what the human independently verifies. If the only thing in front of that reviewer is the AI's own output, the approval click isn't checking anything at all. The timing is what makes this bite. A survey from the AI Engineer World's Fair found agents with write access tripled in a single year. So, more agents that can actually change things, guarded mostly by a human hitting approve. The real question isn't whether you've got a human in the loop, it's whether that human is looking at anything but the machine's own answer. What actually holds up then? Something you can run yourself, that just passes or fails, no opinion involved. And that turns out to be the thing people skimp on the most. Aditya Bhargava, staff engineer at Etsy, wrote a well-known book on algorithms, pointed at a benchmark called Harness Bench. The clever bit is that it holds the model completely fixed. Same model, same tasks. The one thing it changes is the harness, the tooling and the checks wrapped around the model. And the scores ran from about 52% up to 76%. More than 20 points. And the model itself never moved. The weaker the model, the more the harness mattered. Sit with what that does to your budget. Before you pay up for the frontier model, the wrapper around a cheaper one might close most of the gap. If, and it's a real if, you've built a check that just deterministically catches the failures. And the weaker the model, the more that wrapper buys back, which is the whole point if you're trying to run something cheaper, or local, or both. A discipline falls out of this. Steve Yegge, longtime engineer, now building what he calls software factories, has one rule his team follows. When an agent hands back a bad pull request, you don't leave a comment fixing that one diff. You rewind. You change a skill, or a test, or a rule, so that whole class of mistake can't come back. Then you rerun. Because you're not reviewing one piece of work, you're maintaining the thing that writes all of them. A comment fixes today. A harness change fixes every tomorrow. One last one before you go, and it flips the whole thing around to the agent's side. A question that snuck up on me. When agents are the ones writing and changing the code, who's reading it? Or rather, who's still reading it? Mostly? Nobody. Akshat Bubna, the CTO of Modal, they run infrastructure for AI workloads, said something that stuck. His team retooled their whole software kit around agent experience instead of developer experience. And the surface that suddenly matters most isn't the source code. It's observability. The logs, the metrics, the record of what actually happened. So they pushed all of it into the command line, where an agent can reach it and run its own investigation, instead of waiting on a human to open the source. The logic's simple once you say it out loud. If nobody's reading the code isn't where you debug anymore. The behavior is. And if your logs live only in a dashboard a human clicks through, the agent's blind to the one place it could fix itself. Though Bubna draws a hard line, he still wants firm boundaries on what an agent can actually do, not an agent handing itself permissions. Giving an agent more reach is a different question from trusting its judgment. Before you go, one thing worth trying this week. Take one agent workflow you've got, one where a person clicks approve at the end, and ask a blunt question. What is that person actually looking at when they approve? If the answer is only the agent's own output, you don't have a check. You've got a rubber stamp. Give them one independent thing to look at. That's the whole Duolingo fix, and it moved the needle by about a fifth. And if you want to go deeper, one talk worth watching. A developer who goes by Ras Mick walked through how he shipped more than 70 pull requests using agent loops. His one takeaway is the thread running through all of today. A loop only works when the success test is clearly defined and cheap to check. No cheap, clear check, no loop. So, back to where we started. A score that swung from one workday to a whole month, depending only on how you counted the cheating. Proctors 90% sharp, rubber stamping made-up flags. The score isn't proof. The approval isn't proof. The only proof is a check you built that you can run yourself and run again. That's the thing you actually trust. That's today's Agentic Daily Brief. Brought to you by Agent Native Engineering. Open knowledge for building and running AI agents. The full write-ups, with their sources, are at agentnativeengineering.com. See you next time.